Greetings and welcome to the video introduction to Chapter Guide 6 of Chemistry 222, and I'm really glad to have you here. In this section, we'll be looking at basically the study of kinetics. Kinetics is the study of time and chemistry reactions, and it's a fascinating field, quite unlike other things we've done. Kinetics basically is a way to see and explain why some reactions are faster and some reactions are slower. Now, to understand kinetics in terms of chemistry, we first must determine the rate law. And the rate law is basically a set of conditions that helps explain how fast or slow reactions go. And knowing the rate constant and the orders of reaction, stuff like that, pretty important. Now, the rate law is something you totally find from an experiment. You can't make a theory or anything to do it. You have to do experiment to figure out the rate law. But once you have the rate law, then you can kind of make what's called a mechanism to explain why the reaction is fast or slow and suggest some ways to speed up or slow down the reaction even more. A mechanism is always aligned with a rate law, and a mechanism is totally theoretical, all right? You don't have to do really that much in the lab for these. Both of them go together very well, and we'll talk about how they kind of coexist. Now, part of a mechanism is through what's called the energy of activation, and you can think about this as like a barrier that the molecules have to jump to go from reactants to products. If the barrier is higher, it's harder for the reactants to go over to products, so the reaction is slower. On the other hand, if the barrier is very low, then the reactants easily go to products. Those reactions go pretty fast. Energy of activation is super important for chemistry, and we use what's called the Arrhenius equation to figure out what the actual value of this energy of activation is. Finally, we'll extend our understanding of kinetics into nuclear chemistry, the chemistry of the nucleus. And all up until this point, our reactions have been essentially the chemistry of electrons, and electrons are on the outsides of atoms. Well, now we're going to look at a much higher energy form of chemical reactions, which are when the actual nucleus themselves start doing things. So protons and neutrons start migrating to other neutrons, and it's really fascinating stuff. We'll see some brand new types of particles. We'll talk about the stability of nuclei. Believe it or not, nuclei do break down. Half-life becomes really important, both in kinetics and in nuclear chemistry. It's a really fun kind of way to end off Chem 222. If you have any questions on this material, please reach out to me. I'm more than happy to help. Good luck with your studying and have a wonderful day.